Hello, welcome to this mock on antenna basic parameters. My name is José Manuel Fernández González from Universidad Politécnica de Madrid. And this short presentation is about receiver antenna parameters. The index of this presentation is first we will talk about the equivalent circuit of a receiving antenna. Then we will talk about the receiver pattern. And finally, we will talk about the polarization mismatch losses. So, we can define the receiver antenna as a circuit. We will talk about the equivalent generator impedance. We can also consider the receiver antenna as a collector of waves. So the parameters we will see is the radiation pattern and the radiation polarization. So when a wave arrives to a receiving antenna, here we have our receiving antenna, it appears an induced voltage in the open circuit antenna terminal. The equivalent dipole circuit can be modeled as a Thevenin equivalent voltage generator. Here we have our receiving antenna with the load, and here we have the equivalent circuit that we see that here we have the induced voltage and the antenna impedance. So as we say, the equivalent dipole circuit can be modeled as Thevenin equivalent voltage, and it depends on the equivalent voltage, the generator impedance, and the load impedance. Considering only one plane wave arriving from direction theta phi here and sin time variation, the induced voltage that we have in our receiving antenna depends on the field intensity here, on the arriving direction here, and on the field polarization of the transmitter antenna that the wave arrives here. So the definition of the plane wave that arrive to the receiving antenna, we have here the definition. Also, the polarization unit vector can be divided in function of the theta and the phi component. In the receiving equation, constant L here we have the induced voltage, and here we have the constant L stand for an equivalent length used in some wires antenna specification, and F is a normalized pattern of the receiving antenna. Here we have the polarization mismatch losses, considering the wave from the transmitter that comes to the receiver antenna. All the pattern parameters defined in the transmitter antenna can be done in a receiving antenna. The beam width of our receiving antenna, the solid angle main beam, the side lobe level, and the back lobe level. The arriving field polarization and the receiver antenna polarization unit vector must be matched to avoid polarization losses. So we should complete this definition. The polarization unit vector of the transmitter scalar product with the polarization unit vector of the receptor, the absolute value should be 1. So to obtain this condition, receiver polarization unit vector must be the complex conjugate of the incoming field polarization. Here we have to take it into account that both vectors are referred to the same axis system and seen from the same side. This means that both polarization must be equal and rotating in the same sense to be matched. Okay? We need to consider this polarization mismatch. References of this presentation that we have used are detailed here. The IEEE standard definition of terms for antennas, the antenna theory, analysis and design, antennas from Cardama, and antenna theory and design, and also the antenna book. I hope you have enjoyed this short presentation. Thank you very much for your attention.